Okay, so here we go. We are doing lesson 6.1b. Now look, I'm going to try to take enough time to get us done with fractions. You have to do your part. You have to make sure you show the rule steps, because the rule steps is what you need to train your brain. You know, you look on my bulletin board, there's all kind of brain stuff up there. Your brain works a certain way. You have to make the connections in your brain. We have to, in pre-algebra, make the connections in our brain concerning fractions permanent enough to where, well, make them permanent. They have to be good enough to where you're going to remember it not just next week, not just next month, but 5 months from now, and 1 year from now, and 5 years from now. And honestly, fractions are not hard. But you have to do your part by writing the rule step every time. Why? Because writing the rule step is another process in forming those connections in your brain. You have to fire it to wire it. The more you do it, the more you wire the connections in your brain. And so every time you write that rule step, you're helping to make that connection stronger. The physiology of it is you actually make the dendrites and axons thicker, and it helps those connections to be stronger. That's what we need. So pay attention to detail. Pay attention to detail, and there's no reason why fractions have to be a problem. All right, so we dealt with adding fractions with the same denominator. Pretty easy. Now let's get into adding fractions with different denominators. Adding fractions with different denominators. Adding fractions with different denominators. So again, to add fractions, they must have the same denominator. I'm just going to write denom. We just wrote it up above. We don't need to write it again. This must be the thought in your brain. And to try to help you to make sure that that's the thought on your brain, you'll see a short answer question about this on your quizzes, and you'll see a short answer about this on your tests. Because you have to think, every time you go to add, by the way, or subtract, it's the same idea. You have to think, I need a common denominator. I need a common denominator. Now, let me again just try to help you guys understand where we're going with this. Right now, we're just going to be worrying about adding, subtracting fractions. Pretty easy. We're going to figure out how to get a common denominator. But here's the problem. Next, we'll be going to multiplying fractions. And you don't need a common denominator to multiply fractions. So all of a sudden, students forget all about a common denominator to add fractions. Well, that's not going to work. And we gotta focus on what kind of problem it is each time. So again, when you see a fraction that has to be added or subtracted, same concept, the first thought in your brain should be, I need a common denominator. That's what's got to be in your brain. If that's in your brain, you'll be in good shape. Some techniques to figure out how to get that common denominator. Some are very easy, and away you go. All right? So to add fractions, they must have the same denominator. You've got to have that thought. And remember, the rule. Now, this rule involves both addition and subtraction at the same time. So again, we know we add or subtract the numerators. That's why the plus minus. Hey, if it was an addition problem, there would be a plus in the middle, right? If it were a quote-unquote subtraction problem, there'd be a minus. No problem. You guys did problems like that last night, right? I'm showing you both at one time with the plus minus. Don't let that scare you or get you concerned. We're going to add or we're going to subtract the numerators, and we're going to put them over the common denominator. That's pretty easy. And by the way, this then must be the next thought you have when you go to finally solve the problem. So your first thought should be, I need common denominators. Once you get your common denominators, your next thought should be, add the numerators and put them over the common denominator. That's it. That's not a lot. It's two things. As It's not 50 things. It's not 100 things. It's not 11 things. It's not even 3 things. It's 2 things. Get a common denominator, and then add the numerators, put them over the common denominator. 2 things. So those is key to everything. And again, fractions are not hard. All right. There are many common denominators. I think I even say that, right? There are many common denominators. The best common denominator is the, anybody know? You should all know. Say it if you know it. Say it again. I'm thinking letters. I'm thinking 3 letters that represent a bigger thing that we abbreviate. LCD. The best common denominator is the LCD. And remember, when we talked about LCMs, the least common multiple, do you remember how we said that the least common multiple is also the LCD of fractions? We did, right, Christian? So remember, the LCD is the LCM if it's fractions. All right, so again, you got 1/6 and you got 3/4. There are a lot of common denominators. Some people just like to multiply the 2 together and say, let's use 24. Is 24 a common denominator? Yes or no? It is. Can you use 24? You can. You can. It'll work. Is it the best? No. And I'll tell you this, whenever you use anything other than the lowest common denominator, you will always be able to reduce before getting a final answer. If you use the LCD, sometimes you might be able to reduce. It depends on the numbers. And sometimes you won't be able to reduce. But if you don't use the LCD, it always reduces at the end. And so you need to be careful. So 24, somebody give me another, not the lowest, give me another common denominator that's not the lowest. Brendan? 36 is a common denominator. You could use 36 if you want. Anybody got another common denominator that's not the lowest? Nia? 48 is a common denominator that's not the lowest. How about 240? Is that a common denominator? It actually is. How about 24 million? Is that a common denominator? It is. Like there's obviously a zillion of them. But we want the lowest common denominator. It's the best. It is the best. Now, I will say this. If in no earthly way you can figure out what the common denominator is, the lowest, then you can always multiply the 2 bottoms. But again, if we're dealing with big numbers already, now you got a gigantic fraction, and that's not best. It will work, but it's not best. Okay. So, if you can't figure out the LCD in your head, and sometimes you'll be able to do it in your head, then do it the way we learned in Chapter 4. Now, I'm giving you an example that you can do in your head, and we're going to do it the other way, okay? So remember, when we found LCMs, we factored, right? So this 6 is a 2. I'm going to leave a space times 3. And this 4 is a 2 times 2. Somebody raise their hand and tell me what to fill in for the LCD. Christina? Correct. So if you remember, every column gets represented one time, correct? So again, this one I know you guys would have been able to do in your head. Most of you would realize that 12 is the common denominator, the lowest common denominator. But again, we'll try to teach you principles on easy things so that you can do harder ones. So again, normally you wouldn't need to make the chart on a 6 and a 4. My point is, if it's numbers you can't figure out the LCD, figure out the LCM of the denominators, the LCD, and then use it. All right. So on something more difficult, how do you use this? Now watch. This is really the key. And By the way, in Algebra 1, we're going to be doing this with factors of variables and everything. Same principle. And we'll do it the same thing we did with numbers. All right, the key is look at the LCD, look at the denominator, and figure out what it does not have of the LCD. For example, don't do this. I'm doing the 6 right now, right? The 1/6. My problem is the bottom, is it not? I'm trying to get a common denominator. Denominator's the bottom. I'm only worried about the bottom. It's all I care about. What do I need to do to a 6 to make it match the LCD? Well, again, forget that it's an easy number that you know. Try to learn the concept. Do you see how it doesn't have that 2 right there? Therefore, I need to multiply it by the factors it's missing, the 2. And we've already talked about this. Whatever you do to the bottom, do the same thing to the top, right? We're changing its form because we got to get a common denominator. Now look at the 4. Look at its factors and look at the LCD. What factor is it missing? It's missing the 3, right? So again, I'm only concerned about the bottom. I want to multiply the bottom 4 by a 3. Whatever I do to the bottom, I do the same thing to the top. Questions. We'll do this a couple more times with questions, Christina. So I'm looking, first off, I'm dealing with the 6. Therefore, I go and look at the chart of the 6. And I look at the chart of the LCD. The 6 has the 2. The 6 has this 3. The 6 does not have that 2. That's what it was missing. Therefore, I multiplied it by the thing it was missing. Did you catch it? You want me to do it one more time? Okay. So again, because I'm thinking about the 6, I'm looking at the factors of the 6, a 2 and a 3. So, I'll do it this way. The 6 has a 2. The LCD has a 2. The 6 has a 3. The LCD has a 3. The 6 doesn't have this 2. Therefore, I'm going to supply it with a 2. What it's missing. So let me do the 4 now, Christina. So the same thing with the 4. I'm looking now at the 4 factors. It has the 2. It has the second 2. It does not have the 3. Therefore, therefore I'm going to multiply it by the thing it's missing, and the 3. Sometimes it could be missing one factor. Sometimes it could be missing a couple. We'll do this a few more times, and hopefully you'll begin to catch on. Okay, so now let's write what our fractions are. 1 times 2 is 2, and 6 times 2 is 12. We've done this already. Plus 3 times 3 is 9, and 4 times 3 is 12. Do we or do we not now have a common denominator? We do. And again, this is the whole point. So at this step, you better have a common denominator, right? That's what we're trying to do. It's the whole purpose. Okay. Rule step. What does your brain say for the rule step? It should say this. Add the numerators and put the numerator over the common denominator. But again, I'm going to show the addition before I physically do it. That's the rule step. So again, I'm just trying to connect that brain. Got to connect those axions. Where are you guys going? We're not done. Now you got to finish it, unless you're ahead of me, right? 11/12 and onward. Again, don't tune me out. It's an easy problem. You could have done it in 2 seconds from the beginning. I'm trying to show you the process on something that's not very complicated, because it's hard to learn concepts on complicated things. Chloe, question? Only on the ones that you can't figure out in your head. Again, some of the easier numbers, you don't need to fool with the chart. I'm just trying to do it on easy once you learn the concept. Christina. Yes. So the way you multiply fractions, top times top, bottom times bottom. It's the same way we unreduced our fractions in chapter 5. Okay, let's go to the second page. Where's my sheet. Okay, so again, something like 3/5 and 2/3. I don't think you need a chart. Chart would be boring. So on 3, you tell me what the common denominator is, all right? The value of the common denominator. So again, I've saved you a little work by rewriting. So again, this is what we're looking at. This is our problem, okay? So if you had to add 3/5 and 2/3, your common denominator would be 15. And again, that hopefully you can figure out if the numbers are easy. So we don't need a chart. So let's take it one step at a time. What would I multiply the left fraction by on the bottom to get it to be a 15? By 3, right? And whatever you do to the bottom, do the same thing to the top. And therefore, on the right-hand fraction, we're going to multiply the bottom by 5. Again, see, I start on the bottoms because that's what I'm working on, right? The bottom, the denominator. Whatever I do to the bottom, do the same thing to the top. Now I'm going to multiply top times top. 3 times 3 is 9. 5 times 3 is 15. I have a plus sign in the middle. 2 times 5 is 10. 3 times 5 is 15. Now again, you guys going ahead. You better make sure you got a rule step in your notes, because again, when I look at your homework tonight, every time you don't have a rule step, you're not getting that problem correct. Because whether you want to train your brain or not, I want to train your brain. So again, I need a rule step. Now we're going to add them up. And by the way, you always look to see if your final answer reduces. 19 on the top and 15 on the bottom does not. But I'm always thinking it. Christina. Okay, because we said our LCD is going to be 15. So here's what I thought. This was my thinking. This is like what we did last chapter. 5 times what value will give you a 15? And I said, oh, a 5 times a 3 is a 15, so I'll do 3 over 3. On this one, I said 3 times what equals 15? And I said a 3 times 5, so I did 5 over 5. Whatever's going to make my bottoms 15, because first we said the LCD is going to be 15. Show you again on this next one. So here when we get to number 4, now notice we got some negative numbers in there, right? But again, I don't think you need a chart on this one. If you do, do the chart. I think most of you can look at this and figure out what the LCD is. So on 3, tell me what you think the LCD is. Are you ready? Nia, didn't ask you to figure the whole problem out yet. That's why, you know, when I'll give you a chance to do your own, just hang in there. All right. On 3, 1, 2, 3. 30. The LCD is 30. So, again, if you want to figure it out yourself from here, that's fine. Make sure you show your rule step, okay? Be careful with your positives and negatives, but I am going to talk everybody else through it. So, again, I'm going to go to my negative 7/6. See, I just tried to save you guys time by rewriting the original. So, Christina, 6 times what will give me 30? Right, so I'm going to use a 5 on the bottom. Whatever I do on the bottom, do the same thing on the top. And then on the second fraction, 5 times what will give me 30? So I'm going to use 6 on the bottom. Whatever I do on the bottom, do the same thing on the top. So here's my next step. A negative 7 times a 5 is a negative 35. And 6 times 5 is 30. I still have this negative sign in between them. 3 times 6 is 18, and 5 times 6 is 30, and that's where I'm at right now. Negative 35 over 30 minus 18 over 30. Rule step, were you guys careful with your positives and negatives? I hope so. 35 negatives and 18 more negatives. 35, 45, 53 negatives, right? And again, I'm going to think, does this reduce? 53, I believe, is prime. At best, a 17 or a 19, maybe. I don't think so. 51 actually is 17, so 53 is prime, so it's not going to reduce. But I'm always thinking it, just in case, right? Every problem I'm thinking, does it reduce? 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 Okay. So number 5. 4 and 6. If you can't figure out the LCD, do the chart. If you can figure out the LCD, then use the LCD. I think most of you can figure this one out, and you probably don't need the chart. So why don't you guys go ahead and do this one. Use the chart if you need to. If you don't need to, go ahead. I'm going to pause the video. All right, so hopefully you ended up with negative 19 over 12. Now, if you didn't use 12 as the LCD, your answer will reduce to negative 19 over 12. The lowest common denominator is 12. How many got that right? Questions. Questions. Again, we're trying to get a common denominator so we can add them over the numerator. Yes, sir.
How come negative 3 times 3 equals negative 12?
Negative times a positive is a negative. Yes, sir. Never know how to read Edward, right? Okay, 35 and 10. That's a little bit of an obscure LCD. We could go to 350, but is that going to be the lowest common denominator? No. So let's use the chart. So again, for time's sake, I'm going to do it with you. I'm going to do the 35 in blue. It's a 5 times 7, right? And before I write it in, I'm going to look at what my 10 is so I can do my factor as well. A 10 is a 2 times 5. Okay, so I need a 2 spot and a 5 spot. And that's going to put the 5 of my 37 there, of my 35 and the 7 there. Right, so hopefully you agree the chart would be 35 is 5 times 7, the 10 is 2 times 5. Now we know the LCD is 2 times 5 times 7. Agreed? So before I was trying to save you guys time by writing the fractions again. So now this is normally how you would do your problem. You're going to start with your negative 3 over 35, right? So Kristen, what am I going to multiply the bottom by? How'd you know that?
35.
I don't even know 70. I wasn't even thinking 70. And if you're thinking 70, you're not thinking the best way. Because, look, I want to teach you a method that will solve a fraction, look, like this. You see numbers anywhere? Not a whole lot. But if I can teach you this with numbers, later on I can teach you this with factors and variables. So I need to train your brain a certain way. So again, I'm not even thinking 70. So Chloe? Correct. Because again, I look at my 35 and I see my 35 is missing this front 2. And that's why I'm going to use 2. And later on, when the factors are tricky, I can do the same thing. Now be careful, your original problem has a negative in between them, right? And then comes the 3/10. Julia, what am I going to multiply the 3/10 by on the bottom? And y is 7. Say it again. Not really sure? You could say I'm not sure. Or you could say because 7 times 10 is 70, but again, we're not worried about 70. Christina, why the 7? Again, I'm going back to my 10 right here. And I'm comparing it to the LCD, and I'm seeing what it's missing. It's missing the 7. Therefore, I'm going to use a 7 over 7. Okay, your next line, and for time's sake, we're going to go a little fast here. Negative 3 times 2 is a negative 6. Now I got 70s on the bottom. Minus sign. 3 times 7, 21 over 70. Rule step. Minus 6 minus 21 over 70. Do you concur? 6 negatives and 21 more negatives is 27 negatives. Oh, I wish this one would have reduced. By the way, 27 is 3 and 9, right? 70, unfortunately, is only 7 and 10. And 10's a 2 and a 5. So it doesn't reduce, but it's close. But I'm always checking. I'm always checking to see if it reduces. Because I want the correct final answer. All right, let's get to a few mixed numbers here. All right, first off, I don't know why, but a problem like number 7 freaks people out. Don't ask me why. What's the denominator of the 3? All right, so why is that freaking you out? All right. I don't know what to do. Piece of cake. What would the LCD be? 7. And all we're going to do is multiply the 3 by 7 over 7, right? So easy. So now we have 21 over 7 plus 5 over 7. Do you concur? Do you concave? You concave? You don't want to concave. You obtuse? Is that what I heard? All right, cool. Edward is obtuse. He likes being obtuse. That's okay. Add the numerators different, all right, and put them over the common denominator. That's all right. If we were all the same, it would be a boring world. And for space sake, I'm going to put my answer to the right. 21 and 5, we all know, is 26. And again, that doesn't reduce. We've yet to have one that reduces, but I'm thinking it every single time. I'm thinking, can this thing reduce at the end? We haven't had one yet. Because again, remember, using the LCD, a lot of times it won't reduce. Sometimes it will. If you don't use the LCD, it always reduces. Always, 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 always. All right, so again, same kind of problem. Let's skip it, right? That would be easy. We could do that. Let's get down to 8 here. Let me get rid of my shade so I can go higher for you guys. All right, so number 8. So we got 2 mixed numbers. What do you think you're going to do first? Say it if you know it. Got to turn them in proper fractions. Okay. So 3 times 2 is 6. 6 and 1 is 7. Do you agree the first one is 7/2? All right. Now, because the negative sign is between, leave some space and put your negative sign about there. And now all we got to worry about is the 4 and 1/4. What improper fraction is 4 and 1/4? 17/4. Good. So you agree that's where we're at right now. And this is an easy LCD, right? The LCD is? So the only thing I need to do is do what? All right, so all we have to do is worry about the left one, and we're going to multiply the bottom by a 2. Do you agree? To get the bottom before, and whatever we do to the bottom, we're going to do the same thing to the top. So now let's write what we got. 14/4 minus 17/4. Don't forget the rule step. Train your brain. And again, I'll go right, well, I can go below here. 14 minus 3 is 11. Whoa, 3? What is my brain doing? Who's drinking Kool-Aid out there? 14 minus 7, I was like, my brain was already adding them. All right, 14 positives and 17 negatives is 3 negatives. Answer, negative 3/4. Negative 3/4. All right, one more. Hey, be careful with the negative 5 and 1/8. Be careful. You can either do the protocol for the negative in the mixed number, or you can leave the negative in front and do the mixed number. Either way, you should end up with the same thing. What's 5 and 1/8 as a improper fraction? Say it if you know it. It is a negative 41 over 8. So again, if you leave the negative in front, you can just do the 41 over 8. That's still a negative 41 over 8. 3 and 5, 6. Oops, I need a little bit more room for my plus sign. 3 and 5, 6. What is that? 18/23/6. Okay. And again, the LCD, you might need the chart, you might not. I'll show you in the chart, but most of you could do this one in your head. An 8 is a 2 times 2 times 2, and a 6 is a 2 times 3. Therefore, our LCD is 2 times 2 times 2 times 3, correct? So you're going to multiply the 8 by, and whatever you do at the bottom, you do the same thing at the top. And before we finish, you're going to multiply the 6 by what? Right? 2 times 2, which is 4. Again, try to learn it chart way so that when it is numbers you can't handle, you know how to do it. Okay, 41 times 3. Be careful here. This is 123 over 24. And again, there's a negative out front. Plus 4 times 23. That's a 92 over 24. Be careful, we're not using calculators till we're done with fractions, because stupid calculators today can do fractions. But guess what? Can they do them when they have a variable? No. So the idiot students that use their calculators are idiots and never learn how to do it with easy numbers. And then when there's variables, do they know how to do it? No. So don't be an idiot student. Okay? And that's why we're not using calculators yet. All right, rule step. Negative 123 plus 92 over 24. Do you concur? Beautiful. 123 negatives and 92 positives leaves me, what, 31 over 24? Man, we haven't had one that reduces yet. However, what kind of format will I leave my final answer? We had 2 mixed numbers to begin with, right? Can you figure out the mixed number in your head? Say it if you know it. It's actually positive. Oh, it is negative. I'm sorry. You're right. Right? Good job, Colby. All right. Negative 123 and a positive 92. And 7 and 24 reduce. Sometimes that part will reduce. I am checking, right? Now, we didn't reduce one time today. But did I check every time? I checked every time. You got to check every time. All right. Does the bottom of your page have the problem numbers on it? 9 through 15, 27 to 30? Very good then. Do well, train your brain. What do I have to see on every problem? The rule step. Thank you. If you don't need a chart, you don't have to use them.